Okay, Assalamualaikum. So today, we from group 5 want to do lab 4 experiment, which is isomerism. Before we start our experiment, we want to introduce ourselves first. My name Muhammad Shwari Bramli, matrix number 23 DBT 22F1005.
My name is Isomerism bin Arizul. My matric name is 33 DUT 22 F1029.
My name is Nurin Alia Farisha binti Muhammad Hanafi. My matrix number is 23 DBT 22F1017.
And lastly, my name is Zayani binti Abdul Wahab. My metric number is 23 DBT 22F1028.
So, without further ado, we want to proceed to our experiment. So, this is experiment outcomes, which is what we want to achieve after we do the experiment is at the end of the practical session, students should be able to understand the structure and chemical bonding in organic compound, and also to understand the concept of geometrical isomer. So, we start to do our experiment. So we must to go to the link, that the blue link here. So if we click the link, it will show like this on the screen. Sorry, we have technical issues, so we must wait because of unstable internet. So on the procedure, we must to choose a playground. We choose the playground, and then we can go to the experiment questions. We must to answer the question of the experiment. So, wait. So without any doubt, we want to answer all the questions for result and data table. So for the first question is 1A. Build a model of the methane molecule using the atomic ball provided. So guys, what kind of atom that we can use to build a methane molecule?
Carbon and hydrogen, which is one carbon,
One carbon
and 4 hydrogen.
And 4 hydrogen. So for build a methane molecule, we must use 1 carbon and 4 hydrogen. Okay, so this is a methane molecule. So to answer the question 1B, observe and draw the structure of the 3D ball and stick model. So if we want to observe the 3D structure, we must click on the 3D button and it will show the structure, which is this is the structure of methane on 3D ball, in 3D ball, and this is the structure of methane if this is the structure of methane in stick model. So we settle to observe it, and we had been draw the structure. So okay, this is the structure that we had been drawn. This is the 3D ball, and this is a stick model structure of the methane. So we move to the 1C question, which is determine the angle between the sigma bond CH in the molecule. So guys, what angle in the sigma bond of the methane?
Uh,
One
109.5.
109.5, right? So, uh, so in these questions, build a model of the methane molecule using the atomic bomb provided. We didn't attach the picture here, but if we submit, madam can see the picture that we attach on the answer box. So, this is just for our discussion only in the result and data table. So, if madam want to see the real picture that we had been do the experiment here, madam can check on the CDOS platform. Okay, next for questions number 2. 2A, build a model of ethene molecule. So, guys, what kind of atom that we can use to build a ethene molecule?
We use to build ethene molecule. We use two carbon and hydrogen, which is two carbon and four hydrogen.
2 carbon and 4 hydrogen. Wait, we have technical issue again. So, okay, what kind of atom that we should use to build the ethene molecule?
Two carbon and four hydrogen.
2 carbon and 4
Hydrogen.
hydrogen. So, so in this kind of molecule, we can see the name is ethylene. By the way, for information, ethylene is the same name of ethene. So, basically, ethene is the IUPAC name of the ethylene. So, we assume that, not we assume, dia sebenarnya sama je nama dia dengan ethylene. Ethene, ethene is ethylene, ethylene is ethene. Is the same name. Okay. So, we want to observe the 3D structure of a 3D ball and also stick model of ethene or ethylene. So, we click the 3D button and we can see the 3D ball structure of ethene or ethylene, and we can see also the stick model of ethylene and ethene. So, for answer the question number 2, which is observe and draw the structure of the 3D ball and stick model. We had been observed in the playground, that we made the structure of ethene or ethylene before. So, to draw the structure, we had been draw. Okay, so the structure of ethene is become like this. Okay, so this is the ethene structure. You can see the 3D ball structure and also stick model structure. Okay. So for question number 2C, can the alkene molecule be twist freely along its double bond? So guys, can the alkene molecule twist freely along its double bond?
No,
It is not possible,
because
right? It's
yes,
not possible because of
because of free rotation.
free rotation. Is not possible because it's not possible around
Carbon double bond in alkenes.
carbon
Double bond
double bond
in alkenes.
in alkene. So basically, ethene is alkene lah. It had been Madam also dah terangkan the ethene is the alkene lah. So ENE is the alkene compound. So other than that, why cannot why the free rotation is not possible? It is because
it contain pi bond.
it is because contain is not the I bond really. That is a pi bond.
Sorry.
Pi bond. It's okay. So we already answered the questions of 2C. We move to D. 2D. What is the HCH bond angle? So did anyone know what HCH bond angle?
Is one
One,
one 6.6.
6.6, right? So, okay. So, for 2E, what is the HCC bond angle? Zayani,
What? What again?
what is the HCC bond angle?
1 to 1.7.
1 to 1.7. Okay, sorry. 1 to 1.7, right? Okay, correct. So, we move to the other questions, which is 3A. Which the questions is about build a model of 2-butene. So, how we want to build the model of 2-butene, guys? What we need? What the atom that we need to build it? We must have for carbon, right?
We use
Right.
4 carbon
For carbon, yes.
and 8 hydrogen.
Sorry,
We use 4 carbon and 8 hydrogen.
for carbon. Oh, sorry. Okay, for carbon.
Yes, and 4 hydrogen.
Sorry, not 4 hydrogen. It's 8 hydrogen.
Sorry, my mistake. 8.
Okay, 8 hydrogen. So we put here, and also here. So we get but to in. But to in. So basically, but to in or to butene is the same name. So you guys don't get confused for the name. Okay. Okay. So we click again the 3D button because we want to see what the 3D structure of but-to-in or 2-butene. So we can see here the 2-butene structure, which is 3D ball structure, is like this. So we can also pause it to see clearly what how ataupun macam mana bentuknya, macam mana bentuk structure 2-butene ni. So you guys can pause. And also this is a stick model of 2-butene. Okay, so we also dah jawab pun, dah observe dah apa yang dah observe dah apa yang soalan nombor 3 bina. Observe and draw the structure of 3D ball and stick model. So for the drawing of 2-butene model is like this. Okay, like this. You guys can see here the 3D ball structure and the stick model structure. Okay, that had been withdrawn lah. Okay. Don't worry, I can compile later and we submit on CDOS for the result and data and also reference and also the recording. So for 3C, explain how a cis isomer is different from a trans isomer. Okay, for this question, I want Zayani to answer this question. Okay. So Zayani, can you explain how a cis isomer is different from a trans isomer?
So basically, cis isomer is different from a trans isomer because the cis isomer are molecules with the same connectivity of atoms. Cis isomer are molecules with the same connectivity of atom. They feature same side groups placed on same side of a double bond. So that for cis isomer, while for trans isomer, it's because the feature molecules with same side group placed on opposite side of the double bond. Double bond.
So that is the answer for this question. So for 3D question, draw the 3D ball and stick model of cis and trans isomer of Q-butane. So for these questions, the answer is this one. So we can see here cis to butane structure, which is the isomer are molecule the same connectivity atom, that features same side group placed on the same side of double bond. We can see here, which is the atom, the hydrogen atom was in the same side. If we see on the stick model, we can see it clearly. The hydrogen atom in the bahagian atas, di bahagian atas, dua-duanya di bahagian atas. But if we see on the trans to butane structure, which is a molecule with the same side group placed on opposite sides, okay, we can see clearly in the stick model, which is the hydrogen, one ke atas and one in kat bawah. Okay, so that's the difference of cis and trans isomer. Okay. Last, for questions number 4. 4A, build a model of 1,2-dichloroethane. So, how we want to build 1,2-dichloroethane structure, guys?
Two carbon, we need 2 carbon, 2 chloride, and 4 hydrogen.
2 carbon.
2 hydrogen.
2 carbon. 4 hydrogen.
And 2 chloride.
Chlorine. This is chlorine. 2 chlorine. So we get here 1,2-dichloroethane structure of molecules. Okay. So, if we want to know for the question 4B, we must to observe it before we draw, right? So, we click or we push the 3D button, we can see here. This is a 3D ball structure of 1,2-dichloroethane, and here is the stick stick structure, stick model structure of 1,2-dichloroethane. Okay, okay. We had been observed, and we want to draw it. How to draw? Okay, how to draw the structure? To draw the structure is like this. So this is the 1,2-dichloroethane structure. This is 3D ball and this is the model that we have been observed. Lah. Okay. So we dah pun answer the question for B. So we proceed to for C. Can this molecule exist as cis and trans isomer, guys? Nuri or Amma,
Cannot.
can you respond?
Cannot exist.
Cannot exist. Okay, wait. Cannot exist. So, okay. Why cannot exist? We want to answer the questions last. For D, explain the answer in 4C. Why the structure cannot exist on cis and trans isomer?
Because cis and trans
Trans isomer
isomer only can exist
only can exist
on carbon-carbon double bond.
on carbon double bond. Okay, that is correct. Other than that, Amma, because of why? We want to
because
explain.
chlorine and hydrogen attach on a carbon.
Because
Chlorine and hydrogen
chlorine and
hydrogen
hydrogen
attach on carbon.
attach
Yes,
on
carbon.
carbon. Okay. Okay. That's the final question. All the question we had been answered. So for the reference, we had been searching and uh, later we compile it and submit on the CTOS. So that's all from us. Yeah, and also the recording link, we attach it later. So we attach it later and we proceed submit the result and data table and also reference and recording link, and Madam can see on the submissions uh, on the submission on our submission. Okay. So that's all from us. Thank you. And yeah, that's all for lab experiment 4 for isomerism. Okay. Thank you guys for cooperate on this
You're welcome.
experiment. Okay.
Welcome. Thank you too.
Thank you. Okay. So